All right, here we go with another complex fraction. R to the negative 3 plus s to the negative 3 over r to the negative 1 plus s to the negative 1. Now, let's write each negative exponent part as a fraction. So 1 over r to the third plus 1 over s to the third, 1 over r plus 1 over s. Now, if I want to add the two tops, I need common denominator. This is r to the third, this is s to the third. My common denominator would be s to the third, r to the third, s to the third, r to the third. So I need to multiply the top by s third over s third, r third over r third. All right, so let's neaten that up a little bit. So top fraction, the bottom, r to the third, s to the third, all over s to the third plus r to the third. Let's do the bottom. To add these together, I need a common denominator. rs will work. Multiply this by s, this by s, this by r, this by r. So now I can write the bottom as one fraction, SR, s plus r on top, s plus r on top. Now, at this point, I wonder if I can rewrite it as a division problem, right? So now I have s to the third plus r to the third all over r third, s third, divided by s plus r over s r. Change that to multiply. So then I'm going to write s r over s plus r. Ooh, forgot my parentheses. Let's put those in. Do you notice that this can factor? It's a special factoring rule, the cube rule. Let's do the bottom first. So r third, s third. Remember what that factors to? Two parentheses, s plus r, s squared minus sr plus r squared. Okay, now we have everything factored here. Could this be my answer? I see something that can reduce. How about this and this? How about this s with one of these, make it s squared? This r with this, make it r squared? All right, so what is the final answer? Let's get our fraction bar ready. The bottom, I have r squared, s squared. On the top, I have s squared minus sr plus r squared. Hey, can I do that s squared with that s squared? No. Remember, I should have a grouping symbol there. It's all or nothing. So, that's the answer to that. Okay, this is the last example. Notice the top of this complex fraction has three parts. So I need to do common denominators for all three parts. So let's put a 1 underneath here. And what would be the common denominator for all three of those? It would be x squared. So what does this need to be x squared? X squared times x squared. What does this one need to be multiplied by? X times x. So now I have x squared plus 3x plus 2, all three of those tops, all over one fraction, x squared. All right, let's put the big fraction bar. Let's get the common denominator on the bottom. This could be 1 over 1. I want to add these two fractions together. I need a common denominator. You know what it is? It's x. Hope you were right. Okay, so the top here ends up being 1 times x is x, so x plus 2 over x squared. So this is my big complex fraction. let's write it now as a division problem. I wonder, though, does that top factor? Oh, yes, it does. I'm going to write it in factored form when I rewrite it to save a step. So the x squared is on the bottom. This factors, you know, x, that's the first term for x squared. Factors for 2, 2 and 1, plus 2, plus 1. Does it add up to 3? Oh, yeah. Always do a mental check. Now I want to do divided by. Anyone notice a shortcut? You could think the divided by, I'm going to change to multiply and flip it over right away to save a step. You can do that. Just be careful. Don't double flip anything. All right, now I'm going to try and reduce. Do you see anything that can cancel out? Look carefully. X plus 2 with an x plus 2. Notice when I cross these out, I cross out the whole parenthesis at the same time. Don't cross out the individual parts. It's all or nothing. Whole parenthesis here. X squared with x squared. Does that go? Oh, yeah. So, left on top, the only thing I see up there is x plus 1. Left on bottom. Well, when those canceled, remember I should put 1s in their places. I'm getting a little sloppy here. All right, so 1 times 1 is 1. X plus 1 over 1 is the answer. I could also call it just x plus 1 like this. I could call it x plus 1 with a parenthesis. All three of those answers would be correct.